All right, I'm going to start. Okay. We're going to get started here. I don't want to take up too much of our speakers' time. I'm going to remind you all to please sign in. Go to the URL, enter the code and your PID. This is how you get credit for attending. This is the second and final graded guest lecture. And I think that's it. So Tuesday is exam number 2. Reminder that it is not cumulative. I sent out the exam cheat sheet, so it covers everything that you need to know. I'm going to update it after today's lecture to include information from Shuai's lecture on Tuesday and Dr. Brooks's lecture today. And I think that'll be about it. So you'll have a couple of days to cover the last 2. And anyway, so I'm very happy to have Dr. Teon Brooks join us here. He flew in last night from New York City. He's recently promoted to senior data scientist at Mozilla and also has a neuroscience background like myself. And I'm really excited to hear his talk today. So I don't want to take up any more of his time, so I'm going to hand it over. Thank you, Teon. Appreciate you being here.
This. Okay, cool. Awesome. How do I make this? Oops, that's awesome. So, hi everyone. Thanks for coming. Today I'm going to just give you a brief walk through my life as how I became an industry data scientist, and it started in like a classroom like this. So my name is Teon Brooks, as I announced, and I'm a senior data scientist at Mozilla, the makers of Firefox. We changed our logo. Now the fox kind of looks at you, so that's like one of the cool things about the logo, and it's just like new color palette. It's really neat. Okay. Okay, I find it neat. So, yeah, good morning. Today I'm going to talk through 4 major points. How did I get here? What is product data science? And that's primarily what I do at Mozilla. Data stewardship as a concept and a practice that we do at Mozilla. How we think about users' data. How do we actually make sure we're being open, transparent, and privacy preserving? And then some of the teaching that I've done, both internally and externally across cognitive science and also data science. So I'm going to just speak probably for like 40-ish minutes and then just open the rest up for questions. So how does everyone feel about that? Yeah? Can I get some more enthusiasm? Yeah, okay. Yeah, you might leave early, so that's what I'm trying to announce to you. Yeah. Okay, so how did I get here? Also, how many of you are fans of NPR? Do you watch the podcast or listen to the podcast, The Indicator? So, The Indicator is a podcast by Planet Money, and they come up with a number that they talk about every episode, and you'll see this on the slide. So we can try to figure out what the number is. Anyone have a guess of what this 11 is corresponding to on this slide? Any guess? Okay. Yeah. Yes, exactly. So I was in school for a very, very long time. So these are the 3 universities I've been a member of, and I first started at UNC Chapel Hill. I'm from North Carolina, so go Tar Heels. And I did my graduate work at NYU, and then I was at Stanford for a very brief postdoc before I went into data science. So we have a new indicator, and it's 1/10. So instead of doing this like puzzing the class, I'm going to just like indicate what they are. So 1/10 is referring to the number of students at UNC Chapel Hill whose family has an income 200% or low of the poverty line. So UNC Chapel Hill established what's called the Carolina Covenant, and it's this opportunity to allow for low-income families to go to college if they were accepted to UNC debt-free. So I was a recipient of the Carolina Covenant, and that actually helped cover all of my tuition and fees for undergrad, which is great because I was the first in my family to go to college. And this allowed for me to continue school without the fear of burdening debt. So that was one really cool thing that North Carolina did. And while I was there, I was a lab manager for the language and cognition in Brain Lab. So I spent 2 years as lab manager here, and this was a very interesting space. So I graduated in 2009, and now that I'm here, I realize 2020, and it makes me feel much older than I actually realized. So one of the things that happened in 2009 is that we didn't have data science. Data science wasn't a concept or really a thing that a lot of people were thinking about as a career opportunity or something to major in college. So in the past decade, there's been a huge shift and a big emphasis on now teaching tools to allow for us to do a lot of things in this space and to tackle different area studies. So I was in the psychology department and the linguistics department, and my focus was on reading. So I was interested in reading comprehension. How do we go from seeing a word and identifying it in the brain? I thought that was pretty interesting. And at this point, we were trying to figure out what are all the tools and skill sets you need to actually be very productive in the lab. So at this point, we were still using Perl. So a lot of the experiments we were doing required text manipulation. So we used Perl as a programming language. So this was, how many people here know what Perl is? Okay, so we got some hands in the audience. Yeah, so this was my first experience to programming. It was Perl, and also I had one really, really, really bad MATLAB class. So if you're taking a MATLAB class, switch to Python immediately. just throwing that out there. No one at Mozilla uses MATLAB at all. Mostly no one in industry is using MATLAB. We tend to build on a lot of open source projects, Python as one of the primary languages, and R. So I'll cover those two later in the lecture. So yeah, that's just a word of advice. Also, I learned SPSS. So SPSS is a statistical analysis software that allows for you to do your t-tests and your f-tests and all of these different statistical tests you've likely come across. And it got a lot of things right, so it allowed for you to have an intuitive interface that you can click and do your analyses. And if you actually looked under the hood, there was a scripting language that was involved with SPSS. So I actually learned to first do statistical analyses using the scripting language within SPSS. So things change over a decade. You have to. One thing about being a data scientist is that you're nimble and flexible with the changes in the industry. And right now, it's pretty solidly focused on Python and R as the two languages for a lot of statistical analyses. But SPSS was a large contender back then. Also, if you ever go to Google for n-grams, back in the day, in 2006, Google used to send out DVDs of all their n-grams, and you could get 1, 2, 3, 4, 5 n-grams. So I created the first database in my lab for this n-gram so you can see what is the co-occurrence frequency of words and how we can use this to understand how the brain might use these patterns with identifying word sequencing in the brain. And then we did a lot of factorial design. Factorial design is, who can tell me what a factorial design is? Who can tell me what the A/B test is? Okay, yes.
A/B test. So we have two different versions of some software or product, and then you expose a small subset of the population to the test B version, which has some new feature or some new something. And you want to see how they react to that, and you compare that to your baseline.
Sure. Yeah. Great. So factorial design is say an expansion of this. So you can have the A/B, so you have these two different conditions. Then you can have, say, a 2x2 design. So you can say AB and then CD, and then you do all the cross. What happens if you have just you have the matrix, and then you can just see what are these different effects? And you look at the interaction, like across these two different conditions that you're doing in your study. So that's how a lot of psychology experiments are structured, in ways to understand how these two different conditions can affect, like, say, how you're processing language in the brain. So that was like some of my first experience with like experimentation and creating my own experiments. And that's me just in a photo that was just like promotion for the university. We had just started moving toward EEG. So EEG is electroencephalography. We can measure the voltage on the scalp of the head of a participant to understand what the relationship of that is to brain activity. And this was actually what I would begin to do in my graduate work. I would use a different technique called MEG, where we measure magnetic field changes. EEG is related to it. So I started grad school in 2011, but in 2013, I first got experience with open source software development. So M&E Python is a library that I help co-develop, and this is actually how I learned to program in Python. Up until this point, I did not have any Python experience. There was one person in my lab who actually used Python in his master's project, so he began teaching me, and we both discovered that there's this new library that had just really been established for a year in Python, which was to allow for us to do our data analysis that we were going to be doing for the rest of our grad program. So M&E started out as like a C binary library that one person developed at like MGH, and it wasn't like very scalable because not a lot of people learn C or C++, and just their day-to-day interactions with, say, psychology and neuroscience experiments. And Python became a much more tractable language because it has like very good ergonomics and ease of like learning. So we started this project, and what we are seeing here is the brain response of someone who's like seeing an image. So we see around 100 milliseconds, you see this visual activation, and it was pretty neat because we built like all of the data visualizations that allow for us to see the patterns that happen in the brain over time. And that was neat. And to go on with this, I've contributed, like, say, 32,000 lines of code. That sounds impressive, but what happens is that, like, if you just like add a file that has like 10,000 lines, you can also get that. So this is to point out that not every indicator is as it seems, because you have to really know the context behind what gives you this number. So that's just something to just always be suspicious of, like, very large numbers or very small numbers, like actually any number that you come across. So I've still been working with this project, but this was pretty much my last year of active development. I've now moved into a different field, primarily centered on like product data science, and I am no longer contributing to the software package anymore, but I convinced my manager to send me to Paris for a week. So I had 5 days of a sprint in Paris, which allowed for me to like wrap up a lot of projects. And one of the nice things is that all of the people here, we met each other online, virtually. Like, we come from all different parts of the world. The person that's on the far left is one of my colleagues and friends, and he was essentially like my ghost advisor throughout my PhD, teaching me a lot of like MEG methodology and data analysis tools. So, version controlling. So in order to contribute to this project, I needed to learn a few things. One thing is that I went to GitHub for the first time, and I was like, oh, what is this space? So GitHub, as you might know, is a place where you go for social coding. It allows for different people to work on this project and have like issues to track the different changes that they might propose, and pull requests to see features that they might add. And it allows for you to build a team that is very distributed and work collaboratively together. So I remember when I got this one project that I wanted to work on, we were trying to take our data processing pipeline that usually took about 2 hours just to get the data into a format that the software could recognize. So it was just very time intensive. And say you're running 40 people in an experiment, 2 hours for just pre-processing before you can even do any data analysis, it's very time consuming. So what I decided to do with the Python skills that I learned for like 1 month from my colleague and discovering this package online, I was like, hey, I'm going to try to learn Python over my winter break of like my second year in grad school. And I want to be able to take the data that we get from our MEG machine and then read it natively in Python. So the first thing I did was I wrote to the listserv and I asked a bunch of people, hey, I'm trying to do this project. Has anyone tried to do this before? Is there any existing projects? Which is just like a nice thing you should do. If there's like existing projects that you can build upon, I highly suggest that you do that because reinventing the wheel just takes time and your wheel won't likely roll. So what happened with this is that actually no one had worked on it because one thing I should mention about MEG is that there are only a few hundred machines in the entire world. So I think that's even like a very friendly estimate. I think that there's probably like 100-ish, like 110. I could count where they are in the world because there are very few. And just a side note, like MEG came about around the same time that fMRI was becoming very popular. MEG, you would spend, say, a few $1,000,000 on this machine. You could only use it for the head because you're just measuring the activity in the brain. And then fMRI, people are like, hey, we have this machine that we can just like image the entire body, which is great in hospitals when you're like trying to figure out if someone tore their meniscus. And you can also figure out how you can see brain activity in one particular part of it. So hospitals decided to go with that option. And we went with the other one. So we had like this very niche boutique machine, which meant that there's not a lot of like software development that had happened for it. So because of this, I took a lot of different files that people had accumulated over time with like understanding the file format and like where data are stored in this. So it's like the beginning of learning how to do the data gathering and figuring out how things work together. And then I spent about like the next 2 months working on this. So in this first a PR that I made, I said, hey, this is very much work in progress. I'm working on this tool called Kit to Fifth. The system was called KIT. Fifth was the format that we're trying to go to. And I've completed a large portion, but I might need some help on these things. And then I said, feedback is welcome. And the nice thing about commits is that you can write very detailed messages to yourself. So I like to think of like your commit message is a love letter from the past. It lets you know what you're doing at that point in time. It gives you context, which you likely need when you're, say, doing data analysis or you're doing a new project. You can just understand what you were thinking at that time and the motivations behind what you did. And let's see. A month later, and after several comments between me and other developers, I finally get my first PR merge. And it took 3 separate pull requests because I had to learn what a merge conflict was. I had to learn what rebasting was. I spent an hour on a video call with the lead developer, almost in tears, just trying to figure out how it happens. So if anyone tells you Git is easy, they're lying to you. But it's a very useful tool because once you learn the mechanics and how it works, it allows for you to collaborate on projects much more effectively. But there is a learning curve involved with it. So be patient with yourself, take time, work on small projects, and you can master Git. And then I had about 104 different commits, so I can go through and see. It was like, work in progress, this is broken, this kind of works. And From this process, I learned about unit testing. So unit testing is very important and crucial. If you're writing software, you want to make sure it's doing the thing that you're saying that it does. So this is how you can create tests that make sure that if you're creating a multiply function, that if you have 2 times 2, the output should be 4. And you make a test that says that checks that your input leads to the output that you expect. And this is just really good coding etiquette and techniques. And you see this is very much used across the industry in like software development, and it's becoming much more relevant in data science and in machine learning to make sure that the test you're doing, the models you're fitting, gives you the expected output. So that's how I learned Python. Over the past, say the 4 or 5 years I worked on the project during grad school, I really got to learn from a lot of other colleagues and like how they wrote Pythonic code. So you can start to learn like, okay, well, you shouldn't have more than 80 characters on the line, or you should have variables that actually tell you what the variable means. And there are a lot of like these different tricks of the trade that you learn from collaborating with other people. So when you're learning a new language, I would suggest that you do it centered around a project, because you actually get to see like the efforts of you learning that language realized or actualized in something that you're doing. And then 2, pair programming. Pair programming is incredible, and we do it all the time in industry. It's just you and your buddies sitting together and watching each other code. It's like Twitch, but in real life, or you can do it virtually. There's Fluebits, which is what I've used as one pair programming software, which allows for you to like share your text editor with someone else. And you can have a video, and you can just like sit and code together. It might sound like a little dorky, but we're all a bit dorky because we're taking this class. But it's actually very useful because you learn like very cool techniques by just seeing how someone like does something, like how they do an autocomplete, or like how they look up their documentation. It really like provides like things that you might not get to learn online, which is taking a course. So those are some just suggestions. Okay, so I've now taken you through just like the academic trajectory, and through this period, we hadn't really established like data science as an academic discipline until like very recently. So I finished grad school around 2017. The first time I heard about data science was really in 2013. It was when one of my fellow graduate students decided to leave the program and join a tech company as a data scientist. And at this point, I was just trying to understand what it means to be a data scientist, and is this a career opportunity that I would be interested in pursuing? So there's this really good article that's in the Harvard Business Review about the kinds of data scientists. So the term data scientist is very overbloated and overloaded, and there are different aspects of data science that are all equally valid and good that you can pursue. The type of data science that I do is product data science, and I'll walk you through a bit what that means. So, product data science enables companies to make data-driven decisions around engineering, product, and design for its core products. So this is a quote from like my manager, and she used it in explaining like how she frames data science. So the science part enables the company to actually take insights from the data that they have, the data being the data-driven process, and product is what we work on. So Mozilla is best known for the Firefox browser. We're at this point now where we really are trying to innovate in the product space, so we're going to be creating a lot of new products in the next like 12 to 18 months, so look out for it. And one of the things that we need to know is like, how do you learn from your users, and how can you build a product that fits their needs? So that's one of the crucial things of my job, is trying to take insights from users' telemetry data, some data that we get from the product that's sent to us from afar, and trying to understand, do they like the product? Will they return to the product? And how can we blend this data with, say, survey data and other types of indicators to allow for us to build the product that fits our users' needs? So we have 178 experiments that we've been launching recently in the past year. So we take an experimentally driven approach to product design. And you see this a lot across a lot of companies, where we want to run A/B tests, and we want to be able to indicate if the new feature that we're adding will drive user engagement of the product. Do they find it to be more useful to get their job done? Will this allow for them to come back and use our product again? So these are the typical questions we get asked often, and we use this experimenter framework that we just developed, and we have a way of indicating what experiments we're running. We do sample sizing for, say, I want to use 1% of the released Firefox population. So 1%, if we have 250 million monthly active users. So you can actually get, say, a few million users in your study, and you have that type of data to really make inferences about what type of features are being adopted and what type of things do people like within it. So it's a very powerful technique, and we have a way of just keeping track of what experiments are in flight, what experiments have been completed, and we have a way of linking the results of our experiment to a central place that everyone across the entire company can see. So it really allows for us to take insights from data science and use it to make decisions on products that we are creating. So one of the experiments that I'm working on right now is the address bar. So not a lot of people think of the address bar as a product, but it really is. So it's part of our core business that drives revenue within Mozilla. It's how can we get people to information that they're seeking on the web? And we do this through our primary search access point, the address bar. So here we have a new design that we're running an experiment for, and it's if you click into your address bar, we can now show you your top 10 sites that you visit. So we wanted to understand, is this something that users need, users want? So oftentimes we go to, say, Twitter, and when you go to Twitter, you often have to type it out. Would it be nice if you were able to just click it once you type in the address bar? Does that actually satisfy users' needs? So this is an experiment that we just ran, and I'm doing the analysis of. And what we found is that people use the address bar about 5,000 times in a week. So it's very often that the address bar gets used. And this is just clicking in, just searching, and this is just the average user. And it's a lot of interactions that can occur within here. And this is the type of work that I do as a product data science. We add this new feature, and then I write up a report, which basically outlines the design. This is to our key stakeholders, so I walk them through, and this is just like any research paper, but it's really targeted toward giving insights of the critical features that we're testing in the experiment. So I give you the motivations, we give you the design, we have an executive summary, so if you only had say a few minutes to understand, we give you the key takeaway points and the key figures there, and then we have a way of showing you the methods and then all of the diagnostic plots, which gives you these tabs here. So this is using R Markdown, and R Markdown is a document that you can use in, say, RStudio. and it allows for you to have this nice blend of like your prose that you're writing along with the code in one single document. So you can think of it as like the Jupyter Notebook if you've been familiar with that. It allows for you to have a cell for Markdown and like cells for Python, but this gives you a nice like user interface for sharing a report. And this is HTML, so I can throw this up on a web server, and then anyone can just like access it at the company. So I've done about like 5 of these reports here, and it's very useful, so I can point someone to like all of the methods that's involved with it. And one of the things we often do as a technique across the company and on the data science team is bootstrapping. So are you familiar with bootstrapping? Yeah. So we use a lot of non-parametric statistics in order to understand, because things like how long does it take for someone to complete a search? This is something that we just instrumented, but we don't really know what the distribution will look like. So one way that we can actually try to get some confidence intervals on this is not to assume any particular distribution, and we can bootstrap our way to getting like credible and confidence intervals. So those are like some of the techniques that we use within the reporting. And with the A/B test, you can bootstrap the different conditions, and you can look at the differences between those different distributions that you calculated. And those are just used, that is a very powerful technique that is used all the time in industry in order to gain insights to how different products are being used. So data stewardship is a concept that we've been in, a practice that we've actually put to use for all of the different data probes that we collect across the company. So Mozilla is a nonprofit tech company. I work on the corporation side, which is wholly owned by the nonprofit. And given that we have this nonprofit structure, we're very mission driven. And our mission is to make sure that the internet stays an open public resource, accessible for everyone. And one of the things that we want to ensure with that is that we are taking good care of users' data so we want to make sure we're taking good care of users' data as we build products and make sure that we're doing it in very ethical ways. So this is a through line through all of the type of data collection we do, the way we store it, the way that we analyze it, and the way that we share it. So when we say share, it's usually to key stakeholders within the company. We do not sell any of the data. We make it very clear from our policies, like how we're actually being good stewards of users' data. So one thing is that we stay lean. We only collect data that we need, and we have a whole process that goes along with it. We have volunteers from across the company that allow for us to review every new probe that might be collected or might be renewed. So probes are these instrumented features that allows for us to get, say, the count of the number of websites that you've gone to, or say the number of bookmarks you might have saved. And when we go to add one of those probes to, say, the browser, it goes in front of one of the data stewards, and we go through a checklist that evaluates what type of data it is, like what category. So if you go to this link, it explains more of the different categories of data that we have classified. So we have just technical data, which is just like what type of hardware you're using. We have interaction data, which is like the number of bookmarks you've gone to, and we have like clear buy-ins from our policy team of like what type of data we can collect and how we inform the users of it, and what type of data we would need to have escalated. So what's opt-out and what's opt-in. And what we do here, you can actually go to like our probe dictionary, which we make publicly available, and you can look to see all the probes that we have instrumented within Firefox and across our products. So we actually have like 5,401 probes that are active within the browser that allows for us to understand all of the different things, such as like how fast does it take for the first pixel to be painted onto your screen to understanding which buttons in the URL bar you might click, so we can have a better understanding of like how people are using the products, what features should be kept, what features should be deprecated, and allows for us to stay very lean in our development process. So one other way that we deal with, okay, cool. And by being very public about the data that we collect, it helps us build trust and security among the type of products that we do. So we can have, so the Firefox browser is completely open source. That means you can go and inspect every aspect of it, which allows for us to send out a security bounty to make sure we don't have any security bugs for the product. And it allows for us to show what type of data we do collect. And it gives you information about like all of these different probes we do have data collection for. And it allows for us to have this engagement with our users. We can point people to it. We're building up more of a conversation around this. We're starting a data blog so we can talk about how we use data in the projects that we're working on so that we can talk to our fellow data scientists and also interested users and other key stakeholders of like how we are thinking about data as a company. So the lean data principles are the things that our company lives by being open, transparent, and having a look toward data privacy as a fundamental part of our products. So another thing that I do as a data scientist at Mozilla is that I teach data science. So one of the things that I've done in the past year, I've gotten my R Studio instructor training. So R is another programming language. R and Python are like the de facto languages of data science. That's just the languages that we use on a day-to-day basis. And then there's ways that you can blend between R and Python in one document. So R Markdown allows for you to declare a cell for R and a cell for Python. And this allows for you to use the language that you see best suited for the questions that you have and have it all within one space. So I went through like 9 different modules for RStudio. And what I've done with this is that I've taught a few workshops externally with RStudio. So we're trying to understand what are some of the most effective ways that we can teach data science, both within the context of getting a data science job or also just learning data science as like a discipline. And we've been trying out a few different workshops approach. And I've also taught it internally to our user research team. So learning to teach R virtually has been one of the new skills that I've been developing. And it allows for us to now have a broader audience in who we can reach. So data scientists in the past has been primarily PhDs who've gone into this space as they've built a lot of these skills to learn how to do data analysis and these different approaches. As this field matures, we see that PhDs have a very useful role, but we can also train master's and bachelor's level data scientists to also be part of our discussion and be members of this ecosystem that can tackle different questions and different problem sets. So one thing that we did as a company and on our team is that we dropped any requirements for a degree. We tend to look for those who have had, say, data analysis experience. So we have like what we call a job family architecture. So this is a very like business speak, but essentially we have a way to progress from like say a junior data scientist all the way to a distinguished data scientist. And there are like 8 different levels that we have within Mozilla. And we have hired primarily from say level 2 and above, which means that you've had like a master's degree in data science or analytics, or you have like say, a bachelor's, but you have, say, 3 years of like experience working as a data scientist or a data analyst somewhere. And one of the big things about companies is that in order for you to progress into different levels, you have to mentor the younger level. So there's a strong emphasis within industry for training up data scientists on the team. So there are different levels of data science that allows for everyone to be a member of the data science community. So what we've done here, we had our studio training for our user research team. So user research are those who are oftentimes doing in-person interviews with different users of the products, and they have very rich data sources from, say, smaller numbers of participants. Since it's really hard to do in-person interviews for, like, say, thousands of users, they tend to have, like, tens of users. And what we do with this, we often blend the insights from, say, these user research projects and try to find the equivalent in the telemetry data from data science. So we have this natural back and forth in collaboration between the user research team and the data science team, where they find like key insights about how users are using the product, and we as a data scientist try to find those metrics that correspond to those insights. And what we have been working on is like to build up the skill set within user research at Mozilla to allow for them to do that data exploration on their own and feel empowered to do so. And I've worked with the team, and we've gone through a 2.5-day workshop, and this gives them the basics of like how R and RStudio works, how to write reports, how to do exploratory data analysis, what is tidy data, what is the tidyverse, what are all of these tools, and I walk them through all of these modules, and I actually have like the repository publicly available on my GitHub page if you're interested in, and it allows for them to have a space to learn from someone who does data science and to ask the question, and gives us a common framework to start tackling the types of questions that they want to. So we can now all speak a common language. We now know what the IDE is. We now know what it is to do data visualization in ggplot. But now say they want to do a more advanced technique. And we are starting to build modules within the company, and we have all of this recorded, so we have these resources that are available for everyone to learn data science at their pace. So it's really useful when we have like the virtual meetings, because you can get a feel of the room. You can see who has questions. Should I slow down? Should I speed up? And you don't have that luxury when it's just video, because the video is already recorded. So we do a blend of the two, where we're going to try to spin up like, say, every half of the year, we do these different like virtual workshops. And then if you want to catch up throughout that half of the year, you can just watch the videos. So that's one of the things I've done as a data science instructor training within Mozilla. And you see a lot of companies actually do this. So Airbnb has the Airbnb University, which was started by a data scientist to teach other team members across the company key data analysis techniques, how to do SQL. SQL is probably like one of the most important things you should also know going into data science, because everything just revolves around databases and accessing it. So I would say learn Python or R and get very comfortable with SQL, because I write it like every day. And so at Airbnb, they have a way of just, they've built out a whole course offering to become like a skilled data practitioner within the company, even if that's not your key role. So there's a lot of like company buy-in to do a lot of training internally, because it helps level up everyone there. So that's one thing that I've done in terms of teaching. And then there's some other projects I've done in teaching more along the lines of cognitive science. One thing that I've taught is like a DIY Cogside class where we taught 33 students in Thailand, which I had an opportunity to go there. This was while I was in grad school, which is pretty cool. And we taught them how to build hardware that could be used for cognitive science research. We centered it on EEG, so we 3D printed an EEG head array and had electrodes, and we used like an open source EEG microcontroller to get readings out. And then we took apart like a PlayStation Eye camera, so one of those cameras you use when you're just like playing video games, you can like do the interaction. There's some really cool hacks that were online, so we actually took it apart and built a lot of like eye trackers with this. So these were ways to introduce the core concepts of like cognitive science in a way that allowed for students to have a hands-on approach to the different hardware. They can see the data, and we were able to start doing experimentation with it. And one of the last things that I have been working on is the Brainwaves project, which is a way that we can now tie the hardware with experimentation. So right now we have about 4 different types of experiments that a student could be running. And this allows for them to do customizations for, say, the Shroop task, or if they want to use different stimuli for faces versus houses. So these are, if you haven't taken Intro to Cogside, you should do so. It's like an awesome class. And I think cognitive science makes for really great data scientists because they focus a lot on the person. Cognitive science is all about trying to understand the mind and the ways that people act, think, and perceive in the world, which gives you a good framework for understanding how users might interact with the products that you create. So with this, we were able to also connect it to the hardware, so you can see like brainwaves, and then you can run an experiment within it. So those are just like some of the techniques of like teaching that I've done, and what we want to do with this project is also just blend it for teaching just experimentation broadly. So imagine trying to understand how a user is interacting on a website. You could give a mock-up of a website, and you can use the mouse cursor to understand how long they spend in a particular region, and there's a lot of good research done in mouse tracking. So this is one way that I'm going to take this product and like have it applied in our work context to have a better understanding how users can interact with given UI designs. So with this, it allows for us to say, have a mock-up of a product, see how a person would expect the product to go. And this is one of the projects I get to work on as a data scientist. We get some free cycles to just work on like interesting products that could be applicable for the work that we do, or that could be shared open source. So Mozilla is really good about allowing for us to have that space to work. And what the 30 here represents the 30 different schools that we're currently working with over the grant period. So it's been really exciting to have this actually in classrooms and having students use it. And this is a project that I've done separately from my work at Mozilla, but we're looking at all of the intersections of how this could be useful. So with that, I'd like to thank you for your attention, and now I open it up for any questions you might have. Okay, I hear one here.
So I know that with Mozilla, like with Firefox, they often release like nightly builds and like way more like experimental builds. Why does a company like Mozilla do that? And like I don't see many other companies like doing things like that, like releasing builds like that.
Yeah, so with Mozilla, we have the nightly. So you also see this with Google Chrome with Canary. So Canary also comes out. It gives us an opportunity to actually launch a product. So those are typically used by the engineers and QA team, and like also for us to what we call fox food. So dog fooding, but fox fooding it's really bad. Yeah, so we use it for fox fooding, so we can see if a feature is going to break, and if it does, we can see it very early on. So our nightly build has now become, so nightly is supposed to be at the end of the night, you build the product, and then you ship it, and then you can see how it works. And this is usually for like a small portion of the population. And we have now moved nightly to like a twice a day bill, so nightly is no longer like the thing. It's like if I go and open my nightly bill right now, I'll probably have like a green arrow that says I should probably update. And it happens like twice, sometimes 3 times. It allows for us to, so one of the things that we noticed before, and what I probably didn't mention, is that we never used to collect that much data about the product, so we didn't have a way of understanding if the product is working or not. And by releasing the product very often, we can now get the telemetry data. We can see how often is this crashing, how is this affecting load times and speeds, and like all of the different metrics that may lead someone to stay or not on a product. So this is why we do that. And I think more companies don't do it because if you were to break the product really like that often, it would just like lead people away to a different product. So you do see different build processes for like say desktop apps, which has like a longer life cycle versus like mobile apps where you go to your phone and you always have updates waiting for you. And they kind of work on that principle of rapid release, but they try to like not break things. And so that's just like how software has developed both on desktop and mobile. They've now had different trajectories. Mobile seems to have even more rapid, like pretty rapid release, but not daily. Yeah. No problem. Yes.
So I think you said that you had something like 5,000 probes.
Yes.
And so I was wondering, have you ever like rejected a probe? Do you do that often?
Yeah, so when we have say these 4 different categories of probes. So for the technical data and for interaction data, those get approved pretty easily. We still do a review process. We make sure that the probe that they're landing actually matches that category and what's the use case. So we have this questionnaire that every engineer has to fill out in order for that probe to land for the product. And if like it's to have like clear documentation, all of this is public. So you can go to like Bugzilla, which is like our forum for like how all of the bugs are done. And you can see the clear discussion that led to this probe being added. If it's not in category 1 or category 2, it has to get escalated to our privacy and trust team and our policy and trust team, which is now working under our global privacy team. But with this, they have like a more nuanced approach, and that part I am not privy to as a data steward. We tend to distinguish whether it's class category 1, 2, and if it's category 3, we escalate that. And sometimes there are rejections because they're the types of data that we don't want to deal with. So like we wouldn't want to have social security numbers, and I don't think we're going to ask for that, but that would be something that would get rejected. No problem. Yes.
How do you keep track of and kind of keep organized all the different data pipelines that you're dealing with, right? Because that quickly gets crazy.
Yeah, this is a great question. So we've just now moved our entire data pipeline from AWS to Google Cloud Platform. And we have a data engineering team. So what I've just talked about the data science aspect of it. Some companies, especially like really small ones, data science usually encompass data engineering, data science. Like they have to do front end, back end, like all of the things. We have the luxury of having a larger company, so we have a team dedicated to data engineering itself. And they have worked on making a streamlined approach to our data pipeline. One of the things that they're doing now is they've created what's called Glean, which is how we can glean information from data. They really like the branding behind it. So it's now being introduced to all of the new products that we're launching. So it gives one single code repository to collect data for any of the products that we're launching. So now we have like a very modern data collection tool, which gives you the data typing to make sure that when you ask for, say, a count, that you're going to get an integer and not like a float or a string, because that used to be the case with like our old things. So it was very flexible and allowed for very untidy data. So we now like make sure that it fits the proper schema. So this data now goes directly to Google Cloud Platform, and that is a pretty streamlined approach that you say, this is what the schema should be. If the data doesn't follow that schema, it gets sent into essentially like our landfill, and that gets periodically checked by the data engineers, and they see why did this break, and if they can fix it, they can backfill it. So that means add all of that back to the data that we get to use as a data scientist.
And as a follow-up to that, how, as the data scientist, how do you interface with the data? Is there like, do you like some sort of third-party software, or do you directly work with the database most often?
Yeah, so one of the things that we do on our team is that we've built out a tool called Moz Analysis. We kind of like branding. Okay, with Moz Analysis, it uses the Google Cloud API. So since our data are now on Google Cloud Platform, they have written a Python library, and they have an R library, and there's like, I think Python and R are the two libraries that they use. And it allows for you to access the data in their database, and you can pull it into your local environment, or if you want to use a cloud resource, you can say use Colab, which they have, and it's just like right there, and you can just like do your data analysis and pull the data over. And it really depends on, like, we allow for flexibility in like how you develop. We're starting to build some best practices to allow for like rapid experimentation. So the slide that I showed with the experiment report, we are working on creating a template that allows for you to specify, say, this is like how I would query the data. So we now have like a JSON schema that explains like, this is like the select statement that I would want for like this particular variable that I'm going to analyze. And then we take all of that, and then aspects like when did the experiment start, what is the observation period, all of that is just specified in the JSON schema. And now we can pass that to our Moz Analysis. It now has a way of looking up your Google Cloud credentials and writing a table to like the Google Cloud Platform, which is really nice. And then we can put all of the data into a format that we can do, like say our bootstrapping. And now for experiments like an A/B test, we can see, okay, between these two conditions on this branch versus that branch, so we call them branches, we can make diagnostic plots. So I probably I could have walked us through that, but I think it would just be more time consuming. We have a way of getting like our markdown report that will have the final results, and then it would lead the data scientist to go and inspect all of the diagnostic plots. And then the data scientist can just write the prose to go along with it. Say, we started this experiment this day, this is the number of people, and they can actually pull that from the report. And this is our interpretation. So we used to do a very hands-on approach, which meant that every experiment we had to do required such a heavy lift. But now we realize that there are so many things that are common across the experiments that this is the rapid part. It's like now we can take the best practices and just spit out experiments much more often. It's a good question. Yes?
I know you talked about how data scientists use SQL, use Python, use R. Is there any scenario in which data scientists would only use one language, or would data scientists have to go through multiple, like go through SQL and then import into Python using Python and then import it from Python to RStudio?
Yeah, so there's some solutions that allow for you to just stay in one language and only worry about one language. PySpark has been an approach that some of us have used. It allows for you to deal with like distributed computing. So you have a large, we used this more when we were on AWS. So we just had this huge data lake where all of our data just lives. That's what they call them, data lakes. And you pull it in using Spark, which is this distributed programming language. And it has a Python interface. And you essentially write SQL, but as methods to the table that you create. So you say, hey, I want this table. And you're like, table.select, and then you give like your SQL there, but it's in Python, so you don't worry about it. And it allows for you to do what we call lazy interpretation or lazy evaluation. So only when you need to like pull the data will it go through and like send this off and retrieve the data. So you can get a look at what the data schema is going to be and like how all of these things work together as a preview before you have to say collect, and it takes like a few minutes or tens of minutes or much longer for your analysis to happen. So those are some approaches. You could try to do everything in SQL. So Google now has ways for you to do scripting within SQL. So if you want, like one of my colleagues just wrote a Poisson bootstrapping technique within SQL that works, but you don't necessarily need to do that. Yeah. So I think having a core understanding of SQL is just very useful, and I think you'll find that to be in pretty much any setting that you work with data. And then you can choose between Python or R. You don't have to like be an expert in both of them. One is sufficient, I find.
You continue mentioning how you switched from AWS to Google Cloud, and what was the reason for that?
So one of the reasons is that we had an evaluation period for whether we want to continue to support AWS and Databricks. So Databricks is a service that's built on top of like your AWS instance. It supports having whether you spin up your own cluster, should one stay online. So it handles all of that in the background. That just gives you a nice notebook interface. So we were seeing, like, is it worth keeping this setup, or Google was offering their Google Cloud Platform and asked us to evaluate it, and our data engineering team evaluated which one works best for us. And cost-wise, it was better for us to switch. And it really did a huge reduction of development time. So with the data engineering, they were able to start focusing on much tougher questions that they didn't have any time to deal with. So that was one very useful thing.
So one thing that a lot of them are probably concerned about is ultimately getting a job in this domain. So, and what is that job going to look like? And so you've mentioned about data scientist maybe as a job term itself not being super useful, and I have similar thoughts about that. Your job now, what is your job percentage-wise? How much time of your job is doing machine learning versus data cleaning versus writing reports, and versus designing experiments?
Okay, so let's do the breakdown. I'll just close this because I think I spend I'll say 20% of my time is in meetings. So I pretty much dedicate my Tuesdays to meetings, and pretty exclusively just meetings. So, and then I would say about 40 to 50% of my time is dealing with experimentation and report writing. So that leaves about 30%. And this time now with the 30% is spent across both the teaching that I'm doing across the company, figuring out what we want to do, both scaling up across, and also just some research, just formative research within, say, I work on the search and revenue part of the company, so we need to understand how can we make a better product that facilitates search. And one thing is understanding how is search done. So one of the things that's in my backlog is to read the original Google paper of how they made their search index. And what we're trying to do now is carve out more time. This is my role as a data scientist now. More time so that experiments are streamlined because they shouldn't require such a heavy lift, and more time trying to understand the fundamental questions. And I think that is where my research background really comes in, because we're just charting unknown territory of how can we, say, optimize revenue streams, and how can we try to create a better search experience. And so that just requires just understanding the fundamental nature of that. So that's pretty much how my time is allocated. I think when I first began, I think that also is what leads to the senior part of my job now. It's now it's just that go into the unknown and just like be the subject matter expert here and give us ways that we should be approaching this. And one of the other projects I'm going to be working on is like from like a business strategy. It's like doing a case study of Mozilla and just, but that's just like more formative research. Did I answer?
Yeah, so
okay, and then
that was kind of a leading question on purpose, right? So I've told them this before, but I really want to just like continually hammer home the point that a big part of your job, statistics and machine learning knowledge are a critical component of
yes.
your job,
Mm-hmm.
but it's a very small percentage
it is.
of your job.
Yeah.
A big part of your job is writing.
It's reading and writing.
Thinking creatively about
Yeah.
designing experiments and how do you work with data.
Yeah. So like my meeting time and my research time actually accounts for much more than my experiment time. So machine learning is really cool. I don't use any of it in my day-to-day work. And I think in product data science, it's rarely like used because it's just like, well, those are going to be all really bad analogies. It's just like using the wrong tool for something that is like usually very simple. Like regression gets you very far in life. Understanding how like a linear regression works and a logistic regression works will like save you like so much time, and like everything I frame is just usually within those two contexts. Machine learning is like a very hot topic, and I think so the article I suggested breaks down like data science for humans versus data science for machines. The type of data science I do is for humans, and it's like really trying to understand the insights, and you get a very great knowledge from just like non-parametric stats and just like knowing the fundamentals of statistics. And the more machine learning part falls under like the recommendation models, and like that's not part of the data science that I do. So I feel like product data science is less on the ML, more on just like applied statistics. And then the data science for machines is more of like ML and how you can build a better Spotify playlist, which is cool. It's just not what I do. Yeah. Yes.
So being a data scientist, how would you compare your job to, say, someone who works in user experience or user research?
Oh, that's a really, really great question. So we're actually trying to have a better understanding of like how our two teams can like better help each other. So some of the work that I'm doing now is like a lot of the user research part, but from a data science perspective, it's like how are people searching and how do we get a better understanding of that? So I collaborate a lot with like one of our user researchers who's assigned to search and revenue as well. And we go back and forth. She has a great understanding of like how users are, say, some users still go to, say, google.com and then search there instead of going to the address bar and searching there. Trying to understand what leads people to do that versus like one behavior versus another. And she has like a lot of great insights there, and I use that to feel like my questions of like how can we make a better search experience, and how can we both together work with, say, our designers and our engineers to implement that. Different companies do it different ways. I know at Google, their user research team is within design org, and they have like the quantitative user researchers and mixed methods researchers. Quantitative user researchers are more like our product data scientists. One thing just pragmatically in the industry, it's like the pay is different for user research versus data science, and that's just how it is. We could be doing fundamentally the same work, but like quantitative user research and like product data science could be doing the same work, but they're in different families of the organization, so their pay scale is different. So that's one thing to look at. But I think the best type of data science work is when user research is in the loop, and the best user research is when we can see how that goes to scale with data science in the loop. So we have like this very natural like symbiotic relationship.
One last question, I guess. Like, how many data scientists are there? So approximately.
I think we have about think we have 14 data scientists, and then I think we have around 8 user researchers. Yeah. And our company is around 1,100. When I joined, I was, I think, data scientist number 6. So, and that was about 2 years ago. So we've had huge growth there because we are starting to realize that having insights into like how products are and like having us in the discussion really is helpful and making better decisions. So we give a new set of eyes and ears to many teams. Oh, there's one. Oh yeah. So one thing I didn't mention is that Mozilla paid for my fellowship at Stanford. I didn't spend much time on that. So I spent a year and a half at Stanford total. The first year was working on my Mozilla Science Fellowship, which was to build, like help develop tools for open science, especially around neuroscience. So one thing that I worked on during this time, there are 2 things. One is that it paid for me to work on the March for Science. So I was one of the national organizers for the March for Science that happened in 2017, which was pretty cool. They just like paid for me to like help organize, and like we marched on Washington. So I can now check that off of my list. So that was one. And 2 is that I worked on neuroinformatics. So I worked on a project called BIDS. It's the brain imaging data structure. And I worked on the MEG component. And we were basically trying to standardize how data should be in like a folder. So it's a lot of like data plumbing, like what should your folder names be, and when should you use hyphens versus underscores, and it's like a lot of just like discussion and debates about that. And we got a paper out, and we have started to implement this in a lot of software. So I got to learn Mozilla's mission that way because they're all about the open internet, the open web, and science is part of the open web. And I really like the culture. It's like weird nerds. There's something, there's a Mozillian-ness about it. And they have like very strong work from home culture. So remote work is like very important at Mozilla. One of the other things is that stickers are very important. So like, I'm bummed that I took out my sticker collection. I'm going to just try to send some stickers to your class. But so stickers are currencies within Mozilla. So we do a company all hands twice a year where we fly the entire company to one location. And then people are just handing out stickers. And that's like how you have cachet at the company. So I wanted to work somewhere like that. And when they had a job opening, like while I was at Stanford during my postdoc, I saw that they were hiring for a data scientist. And it took me like some months to wrap my head around, should I go from an academic career to an industry career? And then I pulled the trigger and I just like jumped in head first, and I've like loved it since then. So it's just, I felt that I fit into the culture, and I wanted to also have like flexibility in where I live. So I moved back to New York from San Francisco, and about half like 41% of our company is remote. So we have such a strong remote culture that it's totally fine to like pick up and move. So those are things that I really like, the flexibility and the company's mission. I really, really vibe with the company's mission. No problem. Yeah. Yeah, that's a great question. So the question was, I graduated college debt-free. How much did it affect my decision to go into graduate work? I think it really affected my decision-making process because I didn't have to worry about like what my next step was going to be, and it really opened up my mind to. So I was the first in my family to go to college. And I didn't really know what graduate school was. So I got a lot of opportunities at UNC to be in research labs. So part of the Carolina Covenant is that you have a work-study job. And luckily, lab assistant roles were part of like work study. So I got to work in like a cellular neuroscience lab where I worked with mice, and I realized that wasn't for me. So I did that for a year, and then I got into this reading research lab, and I was like, this is really neat. So I think it unlocked a lot of opportunities just being part of like the Carolina Covenant that allowed for me to say, hey, maybe I should explore graduate school. And I learned that like PhD programs are like fully funded. They typically are fully funded. So that's what led me to start exploring there. And I was like, if I can spend some more years learning something that I'm really interested in, I should go for it. And I got accepted. And I learned a lot during the graduate program. Also, is that like learning to advocate for yourself. So it really all added to my experience. So I think it did help a lot.
Thank you.
Thanks.